Okay, so the last section of this unit is about compound inequalities. Compound inequalities are basically when they have more than one symbol. So when an inequality has more than one set of symbols in it, it's called a compound inequality. Compound inequalities create a range of values that work for the inequality that's contained rather than wide open to one side. So if we have like x is greater than 2, then the answers range from 2 to infinity. Compound inequalities can set the answers between like -5 and +7, or sorry, something similar to that. So some examples, 3 is less than x, which is less than 7. What this tells us is that 3 doesn't work as an answer, 7 doesn't work as an answer, but anything in between those does. So 4 works, 5 works, 6 works, 3.001 works, 6.999999999 works, anything less than 7 but greater than 3. And we can graph these on a number line very similarly to how we would any other inequality. So we have 3, 4, 5, 6, 7, 8, 9, 10. So again, we'll start just by looking at one side. So we have x is greater than 3. So we would do that by going this way, and I'm going to just start by shading a little bit this way. And then we have x is less than 7. So again, start this, and then we'll go a little bit this way. And so since this is a connected group right here, we can just connect these. And then we want to check and make sure that we don't need to fill in our dots. In this case, since we have no equal sign and no equal sign, we don't. So these are going to stay open. And this is how you would graph this inequality here. There's also a set of compound inequalities that can be written in an exclusionary way. And so what this means is that they'll give you ranges, and it'll usually have this or sign. So this says x is less than 2 or greater than 5. So let's say I have 0, 1, 2, 3, 4, 5, 6, 7, 8. So I can graph x is less than 2. That looks like this. And again, I'm just going to draw this little line here so I can see which way it's going to go. And then x is greater than 5. Draw this little line here. So you'll notice that this in-between range is kind of open. I'm not going to fill in any lines that way. So this goes all the way out this way. You have an arrow. And then this one goes out all the way this way. And you've got an arrow. So this one basically is exclusionary because it's telling us that any number between 2 and 5, including 2 and 5, doesn't work as an answer. So this kind of eliminates a set of answers rather than provides us with a set of answers. So that's called an exclusionary compound inequality. Solving compound inequalities is a little bit complicated, but it's actually easier than it might initially seem. So basically, the thing we want to do is treat each side of the inequality as a separate problem, and then you're going to solve it as normal. So I'll show you what I mean in this example here. So we have 7 is less than 3x minus 2, which is less than or equal to 13. So what we're going to do in order to solve this is write out two inequalities. We're going to 3x minus 2 is greater than 7, and we're going to have 3x minus 2 is less than or equal to 13. Then I just need to solve these. So this one we solve by adding 2 to both sides. 9 is less than 3x. Divide by 3. And we get x is less or greater than 3. So that's the first one done. Okay, second one, 3x minus 2 is less than or equal to 13. We add 2 to both sides. We get 3x is less than or equal to 15. Divide by 3. We get x is less than or equal to 5. So then we can rewrite this as a compound inequality. So we'll have 3 is less than x is less than or equal to 5. And once we have this, we can graph this on a number line, which I don't have on this slide. So let's just go back here. So we had 3 less than x less than or equal to 5. Now, again, if you were doing this on a test, you would probably want to check both of those answers into the original equality. So for example, here, the easiest number to pick is 4, because it's right in between these. So if I go back and check the original formula, if I plug in 4 here, we're going to have 7 is less than 3 times 4 is 12, minus 2 is 10, which is less than or equal to 13. And this works. 10 is greater than 7 and less than or equal to 13. So this does, in fact, work. So my inequality is probably correct. So again, back to here, 3 less than x, less than or equal to 5. Let's say we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll put the 3 here, and x is greater than 3, so it's going to be going this way. X is less than or equal to 5, so it's going to be here. It's this way. So we're going to fill this in. And then our 5 is included, so we fill this point in. And we are done, just like that. So this is how we can graph the solution to our compound inequality. These ones will probably take a little bit more practice than any of the other ones. But again, all you have to do is separate these into different formulas and then solve them from there. So again, we'll just take this side, call that one problem. And then we will take, let me change the colors so we can see it better. This should show up. And then we'll take this side and call it one problem. We solve each of those separately. We recombine them to make the compound inequality, and then we're done. So that's really all you have to do for these. Like I said, it's not too much more difficult than solving regular equations. It just gives us a little bit of an extra thing to think about. So hopefully you guys, this will be enough to get you going on the practices. I will make a study guide for this. It'll probably take a couple of extra days. I haven't gotten started on that just yet. And I think Ms. Leatherman changed the Algebra 1 version of this test recently. So I want to make sure there's nothing else on it before I get into the study guide. But I think that that should be pretty much everything you need for this unit. Yeah,